Welcome all to this presentation. This video we are studied about the aromatic electrophilic substitution reaction. The aromatic electrophilic substitution reaction is a chemical reaction in which the functional group attached to a compound is replaced by an electrophile. Generally, the electrophiles are electron deficient species. The electrophilic substitution reactions are nitration, sulfonation, halogenation, Friedel-Crafts alkylation and Friedel-Crafts acylation. The electrophilic aromatic substitution reaction, an atom attached to an aromatic ring is replaced by an electrophile, such as nitronium electrophile in nitration reaction, sulfur trioxide. Sulfur trioxide is a neutral molecule. This is also act as a electrophile because of it accepts the pair of electron. Friedel-Crafts alkylation to produce the alkyl cation. Friedel-Crafts acylation reaction to produce acylium ion. In halogenation reaction, for example, chlorination reaction, chlorine in presence of FeCl3 to produce a chloronium ion. In bromination reaction, bromine in presence of FeBr3 to produce a bromonium ion. Nitronium ion, sulfur trioxide, alkyl cation, acylium ion, chloronium ion or bromonium ion. These are act as a electrophile because of these are electron deficient species. Example of such reactions include aromatic nitrations, aromatic sulfonation, and Friedel-Crafts acylation and alkylation reactions. See the equation. The benzene ring containing hydrogen atom. The molecular formula of the benzene ring C6H6. The one hydrogen atom replaced by electrophile to produce an electrophilic substituted product. That product is a stable product. Nitration of benzene. The benzene treated with fuming nitric acid and fuming sulfuric acid to produce a nitrobenzene, and then water molecule will be eliminated. Generally, the fuming nitric acid and fuming sulfuric acid to produce a nitronium ion or nitroelectrophile. Generate the necessary electrophile sulfuric acid, protonate nitric acid, loss of water molecule from protonated nitric acid from nitronium ion. The electrophile required for nitration. Remember that any base will be present in the reaction mixture to produce generally the sulfuric acid used as the sulfate ion as a base. It removes the proton at the end of the reaction or second step of the reaction. Finally, we get the substitution product. Mechanism of nitration reaction. The nitric acid containing hydroxy group abstract the proton from sulfuric acid to produce a water molecule. Nitronium ion electrophile is produced. That nitronium ion abstracted by the pi electron of the benzene ring to produce a carbocation intermediate. The carbocation intermediate stabilized by resonance stabilized by benzene ring. Finally, to get the stable product, the proton will be abstracted by base. Next reaction, sulfonation of benzene. Fuming sulfuric acid. The solution is sulfuric acid or concentrated sulfuric acid used as sulfonate aromatic rings. Benzene treated with sulfuric acid at applied 180 degrees Celsius to produce benzene sulfonic acid. Water molecule will be eliminated. As the following mechanism shows, substantial amount of electrophile sulfur trioxide. Generally, the sulfur trioxide is a neutral molecule. This is also act as a electrophile because of this is also accept the Lewis acidic nature. It is generated when concentrated sulfuric acid heated as a result of neutrophil losing proton. Take a minute to note similarities in mechanisms for forming the sulfonic acid group electrophile for sulfonation and the nitration electrophile for nitration reaction. Mechanism of sulfonation reaction. The sulfuric acid, 2 mole of sulfuric acid treated with to produce finally sulfur trioxide, water molecule and hydronium ion. That sulfur trioxide or acidify sulfonic acid group treated with pi electron of the benzene ring to produce a benzene sulfonic acid. Federkopf's alkylation react and Federkopf's acylation reaction. First, we are see the Federkopf's alkylation reaction. In benzene ring treated with alkyl chloride in presence of aluminum chloride as a catalyst. The aluminum chloride is a Lewis acid catalyst. It is easily accept the pair of electron from alkyl halide. Any other Lewis acid catalyst such as FeCl3, BF3, these are also act as a Lewis acid catalyst. Example of the reaction: benzene treated with ethyl chloride in presence of aluminum chloride as a catalyst to produce ethyl benzene. Mechanism of Federkopf's alkylation reaction. Alkyl chloride treated with aluminum chloride. The aluminum chloride already we know accept the pair of electron. The bonding electron accepted by aluminum chloride to produce AlCl4 minus. The alkyl cation is formed. The alkyl cation treated with pi electron of the benzene ring. The pi electron of the benzene ring to produce a stable carbocation. The stable carbocation will be stabilized by resonance structure. It has a 3 resonance structure. Finally, the disprotonation by base to produce a stable substitute product such as alkyl benzene. The another example, benzene treated with 1-chlorobutane in presence of aluminum chloride at 0 degree Celsius. 1-phenylbutane is an unrearranged alkyl substituent product. The another product, 2-phenylbutane. The 2-phenylbutane is a rearranged alkyl substituent. 1-chlorobutane leaves the chloride ion to produce a primary carbocation. The primary carbocation is a least stable compared with secondary carbocation. When the primary carbocation neighboring carbon alpha hydrogen will be shipped, this is a 1-2 hydrate shift. The 1-2 hydrate shift to produce a secondary carbocation. Secondary carbocation treated with benzene ring. Secondary carbocation treated with benzene ring to produce a 2-phenylbutane. This is a stable product. Generally, the order of carbocation, tertiary carbocation is a more stable compared with secondary carbocation. Secondary carbocation is more stable compared with primary carbocation. Therefore, 2-phenylbutane is a more stable product. It will give 65% of the product. The another example, benzene treated with 1-chloro-2,2 dimethylpropane. This is one of the neobendyl halide. The neobendyl halide, the chloride ion will be left by aluminum chloride to produce a primary carbocation. Because of CH2 have positive charge, this is a primary carbocation. The primary carbocation is least stable. Therefore, the alpha carbon containing methyl group such as 1,2 methyl shift to produce a tertiary carbocation. The tertiary carbocation is more stable compared with primary. Therefore, the tertiary carbocation treated with phenyl ring to produce a 2
methyl 2-phenylbutane. This is a stable product. The product is 100% of the product. This rearranges 1,2 methyl ship. The another reaction, Friedel-Crafts acylation reaction. The benzene ring treated with acyl chloride in presence of aluminum chloride catalyst to produce acyl benzene. Acyl benzene nothing but ketone. The another reaction, benzene treated with acidic anhydride in presence of aluminum chloride as a catalyst. This also produces acyl benzene. Acetic acid as a byproduct. Because of we are using the reagent is acidic anhydride. In acylium ion is an electrophile required for Friedel-Crafts acylation reaction. This ion is formed by reactions of acyl chloride or acidic anhydride in presence of aluminum chloride as a Lewis acid catalyst. Some cases FeCl3, PF3 also used as a Lewis acid catalyst. Mechanism of Friedel-Crafts acylation reaction. Acyl chloride treated with aluminum chloride to produce a basic nature of AlCl4 minus because of aluminum chloride abstract by the chloride ion to produce an acylium ion. The acylium ion is resonance stabilized. The pi electrons oxygen containing lone pair of electrons shifted to the carbon, the oxygen containing positive charge. The acylium ion is rearranged to get the stable intermediate. Finally, the acylium ion abstracted by the pi electron of the benzene ring to produce the carbocation intermediate. The carbocation intermediate stabilized by resonance structure. It has 3 resonance structure. Finally, the proton will be eliminated or disprotonated by base. The Friedel-Crafts acylation reaction contains carbonyl group that can complex with AlCl3. Friedel-Crafts acylation reaction must be carried out with more than one equivalent of AlCl3. When the reaction is over, water is added to the reaction mixture to liberate the product from the complex. The next reaction, halogenation reaction. Generally, the fluorides are least reactive. The chloride and bromides are more reactive. In halogens, benzene react with chlorine or bromine in presence of Lewis acid catalyst such as FeCl3 or FeBr3. We are used as a chlorine reagent. We are FeCl3 as a Lewis acid catalyst. Suppose we are used as a brominating reaction, that time used as a FeBr3 Lewis acid catalyst. The analogous reaction with iodine and fluorines are not synthetically useful because of I2 is too unreactive and F2 is react violently. So therefore chlorination and bromination, most of the electrophilic substitution reaction possible in the benzene ring. The chlorination, the benzene treated with chlorine in presence of FeCl3 to produce the chlorobenzene. In the mechanism, chlorine treated with ferric chloride FeCl3 to produce FeCl4 minus. At the same time, the chloronium ion will be produced. The chloronium ion is the electrophile. That electrophile treated with benzene ring to produce a chlorobenzene. In other words, benzene treated with bromonium ion to produce a bromobenzene. The bromonium ion produced by bromine treated with FeBr3. The FeBr3 is Lewis acid catalyst. The Fe ion abstract the bromide ion to produce FeBr4 minus. The FeBr4 minus has a basic nature. The bromonium ion replaced by proton to produce a bromobenzene. Finally, the protons are disprotonated by FeBr4 minus. This is a consolidation of aromatic electrophilic substitution reaction. One is a halogenation reaction, second one nitration reaction, and third one sulfonation reaction, and fourth one Friedel-Crafts alkylation reaction, fifth one Friedel-Crafts acylation reaction. See the reaction. Halogenation, replacement of hydrogen by chloride ion, chloronium ion or bromonium ion. In nitration reaction, replacement of hydrogen by nitronium ion. Nitronium ion is a electrophile. In sulfonation reaction, hydrogen is replaced by sulfur trioxide or sulfonic acid group. And fourth one, Friedel-Crafts alkylation reaction, hydrogen is replaced by alkyl cation. In Friedel-Crafts acylation reaction, hydrogen is replaced by acylium ion or acyl cation. Thank you.